This question is from the second shift of 24th January 2026 JEE Main paper. If fx is given to be e to the power x plus integration 0 to 1 y plus x e power x times fy dy, then what is e plus f0? Now observe carefully that the integration variable here is y. But the upper limit is a constant here. So this integral does not depend on x through the limits. All the x dependence is basically coming from the term x e to the power x. This is the first important observation to make. So now we will be interested to separate this integral first of all. By separation I mean fx equals e to the power x plus, separate it as in y times fy dy, integration 0 to 1 y times fy dy, and the other one will be x e power x fy dy. So plus integration 0 to 1 x e power x times fy dy. So this is fx now, with the separation being kept in mind. Also remember that x e to the power x is constant with respect to y. This with respect to y is going to be treated as a constant. So this is basically going to come outside. So finally fx can be rewritten as e to the power x plus integration 0 to 1 y times fy dy plus integration 0 to 1. I'll take the x e power x outside, integration of fy dy. Again, another important observation here is that integration 0 to 1, when the limits are all variables, then of course we are basically looking at the area of a curve between two fixed points, which definitely is going to be a fixed value because the function f must be some fixed function, right? So y times fy dy when integrated between 0 and 1 will give you some fixed value. Similarly, 0 to 1 fy dy will give you some fixed value, which means basically this is some constant and this is also some constant. The integrals are both constants. So we'll give them some names. So we're going to refer to them as, for example, capital A is integration 0 to 1 y times fy dy, and capital B would be integration 0 to 1 simply fy dy. Then we obtain or observe that fx becomes equal to e power x plus this is a plus x e to the power x times this would be b. So now we have the function fx in terms of two constants, which those values we presently don't know yet, but this looks very nice. The entire function is now reduced in terms of two unknown constants. This is a very common and key simplification. Often students attempt to differentiate this immediately without noticing that the limits are constants. Had there been a variable, you could have used fundamental theorem of calculus, etc. But in this case, you have to keep in mind the expression is actually simple. Just reduce the structure first, use some simple naming convention, and then operate on the same. One more thing I would like to bring your attention to is that if you put x equal to 0 here, you would be getting f0 equals e to the power 0 is 1 plus a plus this is just 0 times something. Basically f0 is 1 plus a. And we will see how we can make use of this later. We'll return to this later. Now, out of these two constants a and b, I think everybody will agree that b is a simpler problem to deal with because in a you have got one more extra variable associated. So I would be interested in simplifying b first. How? We see that our b that we defined as integration 0 to 1 fy dy, integration 0 to 1 fy dy would become, see, fx is e power x plus a plus x e power x times b. So fy is definitely e power y plus a plus y times e power y times b. This is what we shall be replacing fy with. So fy becomes e to the power y plus a plus y e to the power y times b. Y e to the power y times b dy. See, now this becomes quite a simple integral to solve. This is the key here again that you should keep in mind in questions of this sort. Extremely common problems, common in terms of JEE Advanced level or JEE Main level, but often not very routine questions. So keep this concept in mind, that in place of fy, we basically substituted the function that we obtained in terms of those simpler constants that we named. Of course, we'll simplify, we'll integrate them. So integration e to the power y dy is e to the power y within the limits 0 and 1 plus integration a dy, a comes outside, integration dy is just y from 0 to 1, and here the b will come outside, integration y e power I, y, we can use integration by parts. So first function times integral of second function minus integral of derivative of first function is 1 d dy of y, and integral of second function e power y. Again, integral of e power y will be e power y only. And if you are a regular problem solver, of course, these are extremely simple for you. I'm just trying to be as lucid as possible. Putting 1 and 0 here, e power 1 minus e power 0 plus a times just 1 minus 0 plus b times 1 times e to the power 1 minus e to the power 1, this is 0, minus 0 times something minus e to the power 0 is 1. It's basically e minus 1 plus a, e minus e 0 minus plus 1 plus b. And now this gives us b equals e minus 1 plus a plus b, b gets cancelled. And hence we find that capital A equals, I think it's 1 minus e. It's quite interesting. So we got the constant capital A. Now again, if we are mechanically solving, we might be interested to find out the value of b now. But if you look at the question carefully, the question is simply to find the value of e plus f0. And don't forget, earlier we found out f0 was 1 plus a. So simply e plus f0 would be e plus 1 plus a. But we just found out that a is 1 minus e. So replacing a with 1 minus e, the e here gets cancelled. The answer to this question simply becomes 2. So this problem is basically testing the concept of separation of variables inside an integral and then recognizing constants hidden inside expressions. You have to reduce a functional equation using algebraic formats, and you have to, of course, avoid unnecessary differentiation. So the moment you see constant limits and integration inside another variable, you have to attempt to extract those constants. Most of these problems, they reduce to solving for a few parameters. Another approach might be to differentiate the original equation with respect to x and observe that only the term x e to the power x will contribute inside the integral. And then you might be getting a first order differential equation and then solve for the constants using the integral conditions. It will be extremely longer. So the algebraic reduction approach used here is more economical and definitely exam efficient. See you in the next video.